Okay, you're good, Bennett. All right, so for the first one, we're looking for find all the times where the speed of the particle is 3. So this is the one where our plan is to do what I call make the lines that you trace. So when you do this, you're going to graph your via t function out. And so as far as tonight goes, I'm not going to really pull up the calculator much. We can graph via t, right? It's important that you pay attention to the intervals. So you want to set it to be from 3 to 5. And then once you do that, it's going to block out everything to the left of 3, everything to the right of 5. The only thing you're going to see on your calculator is from 3 to 5. Okay. So then you're going to graph via t, and we want to know where the speed is 3. So I'm just making this graph up. I have no idea what it looks like, but we'll say that's your graph. So if you want to know where the speed is 3, we want to make sure that we know that speed is the absolute value of velocity. Okay, so if speed is equal to the absolute value of via t, it's important that you note that it's absolute value, right? It means we can have two different types of answers. So if I want to know where speed is 3, we want to draw two different lines. One of them is going to be at positive 3. One of them is going to be at negative 3. Okay, so those lines, 3 and negative 3, you're going to use them to find the intersections with the graph. So speed is equal to the absolute value of velocity. And since it's the absolute value, we said we're going to have positive 3 and negative 3, and both of them are going to give me the same result. So now you would type that into a calculator, and somebody that did this, tell me what you get.
I'm not sure if I got it right, but for V of 3, I got 4.397.
Hang on. Via 3, or did we find the intersection with 3?
Oh, wait. Okay, then never mind. I did it wrong then.
Okay, so here's the thing, is that we got to make sure that we understand which one we're looking for. Because now if we said via 3, if you look at where that's at, that just means plug in 3 for x, right? So here, let me turn this off for a second because it's important we know the difference here. So if I tell you here's a graph, let's forget about those boundaries. And let's say here's 1, 2, 3, 4, 5, whatever. Now we're going to go up, and we'll say 1, 2, 3. Let's go higher. 4. All right, let's go with 4. Let's say that I wanted to know where the speed is 4. Now, Helen, if this is via t, if we find via 4 is that spot right there. But we got to remember what we're finding here. This is time, this is velocity. So this is just telling me what's the velocity at time 4. The velocity at time 4 is whatever that is, 1 point something, right? If I want to know when's the velocity 4, we come over from 4, it happens right there. Right here is when velocity, or in our case, speed, is 4. Does that make sense, that difference?
No, yeah, I remember doing it last week. I think
I just
went really fast.
Yeah. So the thing is that your calculator will trace to 4. If I want to know the velocity at time 4, you hit trace 4, enter, you're good. If I want to know when the y value is 4, the only way we can pull this up is by graphing that line that I refer to as a tracer line. So if we graph y equals 4, and I find the intersection, then I have a way of saying, oh yeah, the intersection, the x value of that intersection is the time when the velocity is 4, because obviously the y value of this intersection is 4. It's some x value, comma, 4. We're asking when is the velocity going to be 4. So that's what we were getting at up here. So now I'm saying that since it's absolute value, we should do this with 3 and with negative 3. Does that make sense, guys? Do we have questions? Did anybody do this and get some times?
I got x equals 4.397 for y equals 3.
Yeah, that sounds familiar. And what
And
else?
x equals 4.682 for -3.
Yeah, there you go. All right, so those are the times you're looking for, and you're going to find those by finding the intersections. Anybody have any questions on part A? All right, takes us to part B. Find all the times where the particle changes directions. What is our plan? The particle changes directions when? Somebody?
At the zeros.
Yeah, so here's our graph. Again, just making that graph up, but we'll call it via t. First thing you want to do is set your graph so that it's going from 0 to 6, and then it changes directions whenever the velocity graph crosses the x-axis. So where does that occur at in this problem? Anybody?
I got at t equals 0.553 and t equals 4.548.
4 point, what was it?
548.
Yeah, that sounds correct. All right, so you get 0.553 and 4.548. Anybody have any questions on A or now B? Okay. Takes us to C. How do we write an expression for position? An expression for position, anybody?
You put the integral of v of t.
Yeah, so we're going to integrate. We're going to integrate via t dt, and we're going to integrate it from a bound we know and a bound we want. They want us to find 5, and this problem gives us 0. And when you integrate it, it's going to give you position at 5. Take note they're using s for this. S of 5 minus s of 0. And you can see that they're giving you 10 for that. Is that correct? So do I have that memorized right? Because I can't see it. Yeah, 10. Okay, so any questions on that setup? Okay, next you're going to solve for s of 5. So it's 10 plus the integral from 0 to 5 of via t dt is equal to s of 5. Can somebody tell me what they get for this integral, 0 to 5 via t dt?
I got 34.391.
34.391 gives us a final answer of 44.391 for S of 5. Okay. Any questions on C? Okay, takes us to D. Is the speed increasing or decreasing? Should be nice and easy. If we're going to find increasing or decreasing speed, we need V, in this case of 2, and I need acceleration at 2. So V at 2 and A at 2. We go to the calculator. You've got velocity graphed. So go to your velocity graph, trace it to 2, go to the main screen, type in a derivative, put in 2, see what you get. Somebody that did it, tell me what we're getting for V at 2 and A at 2. We don't care what the answer is. We just want to know if it's positive or negative.
I don't know what the exact numbers are, but I got v of 2 and a of 2 were both negative.
Both negative. Therefore, what are we doing? It's speeding up. Therefore, speeding up. All right, last one. I don't know if we've talked about this yet. Is the particle moving towards or away from the origin at t equals 1? Let's talk. Towards or away from the origin? First off, what's the origin?
0, 0.
Got it. All right, so what's the first thing I need to find to be able to make sense of this question. I've got a
X
particle. It's the what?
Is it the X value?
Yeah, what do you mean by X value? The what? What does X value stand for? The X, what are we looking for?
Of the position?
Yeah, exactly. Good. We want the position. Perfect. So I want X of 1. Now, here's the thing. Think about what this gives me. When I get X of 1, it's either going to, I don't care what it is, but it's either positive or negative. If it's positive, it's on one of those two axes. If it's negative, then I'm down there or down there. Just think about where a negative or a positive number would exist. So once I know where the thing is, so in this problem, somebody tell me what it is. Is it positive or negative? Position at 1.
I think it's positive.
How'd you find position of 1, just out of curiosity?
I kind of guessed, to be honest.
Kind of just guessed? Let's do better than guessing. Helen, what'd you say?
Take the integral.
Integral of what?
V of t.
There we go. So it's an FTC problem, fundamental theorem. V of t dt, I want 1. What's the bound they give me? The bound they give me is 0, right? So that's S of 1 minus S of 0 is 10. Go through and solve this. We're going to add the 10 to the other side. 10 plus integral 0 to 1 v of t dt. What do we get when we do that, Helen?
I actually don't have my paper with all of the like work on it.
What'd you get for X of 1, a positive or a negative?
I got a positive number.
Okay, so if we're getting a positive number, that means my particle is either right there or right there. All right, sounds good. Now, after you do that, what do we need to find next, guys?
What way it's going?
How do I do that?
You see if it's positive or negative.
See if what's positive or negative.
Velocity.
Exactly. So the next thing I want to find is velocity at 1. I want to find v of 1. Remember the results. If velocity is positive, think about what that means. It either goes up or to the right. At that point, if my particle is going up or to the right, is it towards or away from the origin?
Away.
Okay, and if my velocity at time 1 is negative, am I going towards or away from the origin? If I was heading down and to the left, wouldn't it be heading towards? Hopefully that makes sense. All right, so now all you do is just go into your calculator, find velocity at t equals 1. Helen, what'd you get when you did that?
I also got a positive.
Got a positive. All right, so if that's the case, this is heading up or to the right. So is this heading towards or away from the origin at that point?
Away.
Does that make sense, guys? Does anybody have any questions on particle motion? Lively bunch tonight. All right, get a blank piece
Wait,
of
I have a
paper out.
question.
Yes, fire
Does that
away.
kind of question need an explanation? What would you say for the explanation?
Yeah, so you kind of justify it just like you do speed increasing or decreasing. So speeding up, slowing down. You would just say away from the origin at t equals 1 because, and then the because is s of 1 is greater than 0 and v of 1 is greater than 0. So you just say what your answer is, and then your reasoning is because say the position is positive or negative, and then the velocity is either positive or negative. Okay. All right, guys, blank piece of paper in your notebook. Blank piece of paper. All right, here we go. Things they can ask you. We're going to make a study guide because we're never going to be able to spend a whole class period on particle motion again. So we're going to recap what's what. So this would be particle motion in English. What are they asking you? What do you actually have to do? Not no math gibberish, no nothing. Just get to the point. What's the plan? You should be able to look at a problem and know the plan. If you know the plan, you'll be okay. So things they might ask you. They might ask you to find total distance traveled. Okay, if they ask you to find total distance traveled, what's the plan? Somebody's got to know the plan. Total distance traveled, what's the plan?
I think
That's
the integral.
Integral of,
absolute velocity, absolute value of velocity.
there you go. That's the plan. It's a calculator problem. Punch it in and see what you get. Next. Let's go with speeding up or slowing down at t equals scribble, whatever. What's the plan?
Check A of t and V of t and see if the signs match. If they do, it's speeding up. If they don't, it's slowing down.
So we're going to find these two things.
Yes.
Good. And then if it's the same sign,
It's speeding up, and if it's
Speeding
the
up.
opposite sign, if it's different sign, it's slowing down.
that's all you need. So if you know the plans, we're going to go through each one. If you got a plan when you see it, you'll be home free. It's just a matter of typing it out. All right. So that's total distance traveled, and then speeding up and slowing down. All right. Let's take a look at, let's find the position at t equals something. And you're also going to know that somewhere you're going to know this, given that x of, we'll go with blue scribble for this one. Given that x of blue scribble is equal to whatever. So the blue thing's the bound they give you. The red one's the one you're looking for. How do we find position if we are given one of the position values? What is it that I'm integrating?
The velocity.
That's it. So we're going to integrate from a bound I know and a bound I want. And we're integrating via t dt. And when you do that, it's going to be position at one of these minus the position at the other. And then what are we going to say here? One of these, you'll know one of them. You'll know one, and then solve for the other. And for this piece right here, you're going to just use the calculator. Fire this into a calculator. Does that all make sense? Hopefully. All right, so I'll give you a second to copy here. That's a lot of stuff.
Can you explain the you will know one solve for the other part?
Yeah, so it's going to say find the position at t equals red bound, just for the sake of my explanation, given that usually this piece right here is up at the top of the problem in the directions, the blue bound they give you. So one of those are going to give you. So like if you look back to, where'd we go? All right, so here's the problem we just did. So if you look at the one we just did, Sarah, up at the top, look what they tell me. They tell me that we know S is 0 is 10. So whenever I need to find one, it's going to be the bound that I have information on in this problem is bound 0. So if you look at question C, find the position at t equals 5. So my bound I want is 5. The bound I know is 0. So whenever I get x is 0, or in this case s is 0, maybe the same thing, I get to substitute 10 in. So whenever you're doing one of these bounds they know. So like this one would be s or x of 0. I'd replace that with 10 or whatever they tell me. Make sense?
Yeah.
And then this piece will be out of the calculator. Okay, does anybody need more time or are we good? We're gonna do, there's 7 of these things they can ask you. We've got a blueprint for 3 of them. You need more time or are we good? All right,
I'm
moving
good.
along. Okay, next thing they can ask you, number 4. They can ask you to tell us when's it change direction. When does it change direction? What's the plan? When's it change direction? How do I do it?
You find out
You're
where
just
these
gonna graph
bounds
it,
are
and then you're
for
gonna find the zero.
VFT.
Graph what? Which function?
The velocity function.
Yep, good. All right, so we're gonna graph via t and find the 0 or zeros. And then we're gonna make a note that says pay attention to the interval, because it's gonna say, when's it change direction? Always pay attention to the interval. Set your window to whatever they tell you. Okay, next, it might tell you when is the speed equal to whatever. Red scribble for whatever. All right, what's the plan? Did one of these earlier tonight. What's the plan?
You're gonna graph it again.
Okay, we're
And then
gonna
you're gonna-
graph
Yeah. And then you're gonna
via
find the other
t,
point.
graph via t, and then what else do we graph? We graph the tracer problems, right? So graph tracer lines. And that's the problem where you're gonna get 2 answers. And the answers are intersections. So that's the one where we were gonna graph it or whatever, and then you graph its absolute value. So we graph 2 of them. We find the intersection. Remember that speed is the absolute value of v of t. Okay, next, you could be asked to find is, or not is, how about at t equals whatever, is it moving toward or away from origin? Give me 1 sec, guys. I'm sorry, I got a phone call I need to take. Write out a blueprint for me about what you would need to do for this one. Give me 2 seconds. I'll be right back. All right, I'm sorry about that. Plan for number 6. What would we be up to here? Find what?
The position and velocity at whatever.
Yeah, so first thing I want to find is find the position at whatever. Then find velocity at whatever, exactly. And then after that, I don't really have much else I can give you for the way of clues. This is just going to be kind of use some logic, right? So once you get the position, just remember that positive, positive, negative, negative. Think about where things are positive and negative, right? If you were to put a number on the line, and then once you have it, just remember that a positive velocity, if v at t is positive, we're heading up or to the right. If v at t is negative, we're heading down or to the left. And then you kind of just see where you're at and map it out and you think about it. Okay.
Is there like a rule for speeding up and slowing?
For speeding up and slowing down, hold on. For that was number 2. Which one are you talking about? Say it again now. You there?
Yeah, sorry, my internet cut out.
That's okay. Go ahead. Say it again.
For the moving away, moving towards the origin thing, is there a rule like for the speeding up, slowing down, where it's like if the signs match?
Yeah, there is. I just don't teach it because it's nothing that's like worth memorizing. I think you're way more likely to get this correct. We did try that one year where we tried to make rules, but there's like nothing that really stuck. So to me, you're better off here, pinpoint the position, and then once you know where that position's at, then just apply the velocity and know which direction that gives you. If you're truly looking for something, one year they made up this, but it doesn't stand for any, it doesn't like, there's no way to memorize this. It was opposite signs go towards, or no, this was an A. I don't even remember what we made up on. This was an A. Let me try that again. It didn't stick with me either. Opposite signs go towards, same signs go away. But nobody remembers this. As you see, I just screwed it up too. If these signs are opposite, it's going to go towards the origin. If these signs are the same, it's going to go away from the origin. But to me, I think you're better off just find the position, put your finger on the line, and then find the velocity and go from there.
Okay.
Okay. All right. And the last thing they can ask you, I think, is number 7. You can be asked to find average velocity. How would we find average velocity in one of these free response problems? We got the formula for velocity. So what should we do? Average anything.
Slope.
That's average rate of change. That one's the only one. That's the one where it's slope. We have an integration formula for this. What are we looking for?
This is the 1 over b minus a,
Yeah.
and then the result of the integral from b minus a.
Yeah. So for this one, this would really be, although what you said isn't wrong, Will, this is just an easier way of getting there. So this would then be, because we're going to have that velocity formula. Make sense? Any questions, guys? That is particle motion, all 7 of those. So hopefully that makes it a little easier for you guys whenever you're looking at these, that you can look at it and you have a plan in place. So now let's go back and let's look at the second page and see what we come up with now. So for the second page, we're not going to actually do these. Let's just talk out a plan. Average velocity, literally what we just talked about. So that's going to be 1 over b minus a, 1 over 3 minus 1, times the result of the integral of velocity from 3 to 1 for your bounds, and then you would go through and get an answer. Okay. For part B, when does the thing change directions from 0 to 2? So first and foremost, set your bounds to 0 to 2. So we're looking at the right thing. And then particle changes directions when the velocity is 0 and it crosses. So you would find the zeros and see where it crosses. C, total distance traveled. Integrate the absolute value of via t dt and this problem from 0 to 2. D, is the speed increasing or decreasing at t equals 2? You should find v of 2, a of 2, compare the symbols. If they're the same, speeding up. If they're different, it's going down.
Sorry,
And-
back to C for a second. So for total distance, would that always have to be positive?
Yes, total distance is always, that's why they give you the absolute value symbols. So
Got
the reason for that is that if you didn't put the absolute value symbols in and you integrated it, it would end up wiping itself out if the story you were telling was like, I went to the store and I came back. So if you didn't have absolute value symbols, even though you went like 3 miles to the store and 3 miles back, you understand in that story you went 6 miles. But without the absolute value symbols, your calculator would give you a 0, because coming back to, like, say you're just traveling left and right, going to the right would be a positive, going to the left would be a negative, and then they would just like wipe each other out and it would say you didn't go anywhere.
Mr. Baker, for number 2 or for part B,
Yep.
I got an error. I plugged it into my calculator multiple times, but got an error. It said there was no sign change.
Oh, okay. That means that you've got to go, remember how it says left bound, right bound, guess?
Mm-hmm.
You've got to go left and right of the 0.
Okay.
So
Yeah,
that error,
The graph on the calculator was really weird. It like kept skipping over the x-axis. It wasn't like one line.
are you in radian mode?
Yes, I believe so. Because it worked for all the other problems.
Do you have a calculator with you?
Yes.
Okay, hold on one second. Let me get my calculator. All right. Can you read to me the equation that I'm, oh, hold on. It's not loaded yet. Hold on. I agree. What is the name of that file? TI something? All right, let's try that. Okay. Can you read to me what I'm graphing?
Cosine of e to the t over 2.
Cosine to the e, you said variable over 2?
Yep.
All right. Do we have an interval for this?
0 to 2.
0 to 2. All right.
Yeah, that's the graph I got. And it was
Gotcha. Okay, I see what's happening. So, do you see how it's like really squeezed around, like it's really close to the x-axis there? Like you can't really tell exactly where it crosses.
yeah.
So to make this work, you got to go left and right. Means you got to have something above the 0 and something below the 0. So now, since I don't know where this crosses, it's somewhere. Here's how we can get a better look. Since it's so squished around the x-axis, go to your window and let's change this. Let's make this like -3 to 3. And now look what happens. See how I have a much clearer idea of where it's crossing? It zoomed it in for me because I squeezed around what's happening now. So now when I do it, I'm going to do second trace. I'm going to go to the 0 and hit enter. Now I have a very clear idea of where the 0 is at, so I can easily go to the left of it. Like very obviously the 0 is like right where my arrow's at. It's no problem going to the left of it. What was happening to you is that you were so squished into around the axis that you were doing like this. That was your left bound. And now watch, I'll go like right there. That would be your right bound. But in this graph, is that to the right of the 0?
No.
No. So the thing is that you just couldn't tell because it was so squished around there. That's what it was meaning by no sign change. It means that you were just going, you weren't going far enough, but you just couldn't see it. So anytime that's the case, just change the window and play with it until you can see it better.
Okay, perfect. Thank you so much.
Yep. We good there, guys? Any questions? Okay, let's go back, and I'm gonna have you guys all tackle part E on your own because I'm assuming we all had trouble on this. So let's read E. If you can do E, you've got particle motion down. You understand what's going on. It says between 3 and 4. So first things first, turn your calculator to a window of 3 and 4. The particle changes directions exactly once. Find the position of the particle at that time. So this is a cool question that has you do a bunch of things. So between 3 and 4, so first off, change the window to 3 and 4. The particle changes directions once. Pause. Stop right at the end of this sentence. How do I figure out when a particle changes directions? That's the what?
0.
Okay, first things first, find that time. Then, after you get it, find the position of the particle at that time. How do we find position? By integrating the what?
Velocity.
From a time that I want and a time that I know. So the one that I get is 0. So one of my bounds is 0. My other bound is going to be the spot where it changes directions. The particle changes directions once. Find the position at that time. So you're going to go find that time and then use FTC and go through and do all this. You've got about 3-4 minutes and we'll go over it. Ready, go.
What was the function one more time?
Cosine, and then inside its parentheses was e raised to the t over 2.
When we round, do we just truncate the number or do we, you said it was 3 decimal points?
Yes, so write 4 of them out and then round back to the third one.
Okay.
All right, that should be enough time. So what did we get first off for, what did we get for, when did it change directions? We're at,
I got 3.100.
that's what I got too, 3.100, so 3.1. And then when you integrate that, that's going to be x of 3.1 minus x is 0. What did they tell us x is 0 was equal to?
5.
Got it. All right, so now we're just solving for x of 3.1. So I'm going to add that 5 over. Okay, what's up next? We need to put this into a calculator. So what'd you get when you put it into a calculator?
I got negative 1.072.
Yep. So final answer?
$3.928.
If that problem makes sense, guys, I think you're very, 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 very in a good place right now. That's a lot of calculus. You're into the main part of the year now. There's still a few things I got to teach you, different lessons, but if that's making sense, you're grasping calculus pretty good at that point. Any questions? Any thoughts? Okay, that's just about an hour, so we'll call it quits there for tonight. Tomorrow, we'll be flipping through the other